Hello class, this is lesson 6-2 in your textbook titled How to Relate Transformations and Similarity. Okay, we talked about transformations before and there were 3 different types if you recall, but there's a new one that we're going to talk about now which is called a dilation. And here's what a dilation is. It is a transformation that preserves angle measures with new proportional lengths. So they don't look exactly the same. They look like similar shapes. And so really what you're looking at is an image that is now being enlarged or it has shrunk. Okay. So you're going to either enlarge an image or you're going to shrink an image. That's what a dilation is. So to begin with, we have 2 triangles and it looks like they're on the same shape, but let's just look at what it's talking about. It says that triangle FEG is similar to this bigger triangle FDH. And it wants us to describe the dilation that moves this smaller triangle onto this bigger triangle. Well, first let's just talk about where it's starting and where it's going to, and it's actually starting at this letter F. We're going to call it the center, okay? But the center is right there at F because it's not like it's moving the shape somewhere else to the left or right or down below. So it's staying put at F, but the other points are changing. So we're going to say that this new figure is a dilation with center F. Okay? And the other thing that we need to say then for it to be a dilation is what we talked about at the top, that it preserves new proportional lengths. So we talked about the scale factor in the last lesson. So let's find what the scale factor is. So the scale factor we're going to find it by comparing the new image to the old. So the new one is FH, that's one side that I know measurements on, compared to FG of the old image. And I cannot write here. FG, there we go. So FH is 10 plus 10, which is 20. FG is 10. So it looks like the scale factor is 2 to 1, or it's 2. Okay, so it is a dilation with center F and the scale factor is 2. This is what you would write. That's describing what's happening. It's a dilation starting at F, but the scale factor, it's enlarging by 2. Okay, and again, I just want to make sure that you're always starting with the second image. So here it's saying triangle FEG onto triangle FDH. This is the second image, so that's the one that you're going to start with. Here's our next part. I have another example. The triangles are similar. So we're told that in the beginning. What transformation or transformations move the purple triangle onto the orange triangle? Okay. So I'm looking here and it doesn't look like the second triangle, the orange one, is moving to the left or to the right. It looks like it's staying put, similar to the last example. And we'll notice that because they're overlapping. So when that happens, we're going to say that it is a dilation with center B, because that is the common point in both of those images. Okay? And so then, like in the last one, we need to find what the scale factor is. So the scale factor, you're going to look for 2 sides that you know information about. So I know kind of the base of both of these triangles. So we're going to compare the new one, which is the orange. So all the way from E to B is one side that I know the measurement of, and also from C to B. So E to B would be 8 plus 6, and C to B would just be 6. So that's 14 divided by 6, which equals 7/3. So to write my final answer, it looks like there's only one transformation happening. So I would say that there is a dilation with center B and a scale factor of 7/3. And that would be my final answer to describe what transformation is happening. It's a dilation centered at B with a scale factor of 7/3. Okay, so here's another one now. This time I have not triangles, but some different polygons, and I'm told that they're similar at the beginning. And I'm asked what transformation or transformations move the purple onto the orange. So this time the beginning shape is bigger than the smaller one. So when that happens, you're going to be looking for a smaller number. And it looks like it is a dilation again. But there's no center this time, if you can tell, because the two shapes are not overlapping. So I'm not going to include a center. But let's go ahead and find the scale factor, because it is changing. So let's start with the new one. This time it's going to be dx is one of the sides that I know, compared to AD, which is the old base. So dx is 6, AD is 9, and that simplifies to 2/3. Okay, so it's a dilation with a scale factor of 2/3, and also it is rotating. Okay, so really what's happening is first you're doing a dilation, which means you're going to shrink it in this case. And so it's going to shrink into something like so. And so that's the first step, is the dilation, and then I'm going to reflect it, and it's going to fit perfectly right onto the orange. So I'm going to say dilation with a scale factor of 2/3, and then a reflection. And that would be my answer. Okay, we're going to look at one last example now. And this last example, you're actually told to use transformations to explain why these two figures are not similar. Okay, it kind of looks like they are similar, so we're going to need to do a lot of work to figure out why they are not similar. Okay, so why don't we go ahead and look at the scale factor, because maybe that's it. Maybe the scale factor is not the same when we're comparing all of the sides, so maybe that's the problem. So why don't we compare, it's going from this is the old one to the new one, so we're going to start with the new one. So RS compared to FE, and let's see if that is it. So RS is 28 and FE is 14, and that simplifies to 2/1. Okay, so then the next sides that we're going to compare, so that was FE, let's compare FG, and that should be on the bottom, to ST. So ST is 30 and FG is 15, and again this is 2/1. Okay, so it looks like those are the same, so it might be somewhere else. So let's just keep comparing. How about 28 over 14? Well, that's going to simplify to 2/1. 32 over 16, that's going to simplify to 2/1. And 20 over 10, that's going to simplify to 2/1 as well. So I'm not going to write all these out, but the scale factor is the same for all of the corresponding sides. Is 2/1 for all corresponding sides. Okay, so it looks like we're going to do a dilation because the scale factor is the same. So if I was going to enlarge this greenish yellow shape, okay, I've already kind of done it for you. So this is what it's going to look like. Okay, and just to show you that I am not lying, I doubled, because that's what the scale factor is, all of the sides. So the base I doubled, and then this side I doubled. So I doubled all of those so that the scale factor would be the same. So far, I mean, it kind of looks like, you know, now I just have to do a reflection. So let's see what this would look like. So if I had my reflection line right here to go down to the bottom, and if I reflected this pink onto the blue, you're going to see that even though they have the same lengths, they are not lining up, okay? So those sides did become the same, but the angles on the inside did not line up. So hope that that kind of made sense to you. Let's write down in words now why they were not similar, okay? So we could say that it looks like a dilation, because the scale factor was 2 to 1, but when a reflection occurred, it did not fit exactly. On our STUV. So since all corresponding angles are not congruent, the figures are not similar. Okay, and that's what we're going to write for our explanation. I mean, we did a lot of work to see if it was a dilation, and it seemed like that worked out, but then when I did the reflection, we noticed that the angles were not congruent, and we know that the angles, when they're corresponding, they have to be congruent for the two shapes to be similar, and so we showed that that wasn't the case. So that's what we have. So I hope that this was understandable to you. So come with any questions that you might have to class, and I'll help you out then.